Good afternoon. Today we're going to be looking at the topic called compositions. A composition is a new way that we're going to be thinking about evaluating a function. Now you might remember evaluating means that we're going to be plugging in. Now the thing about this is we're not going to be plugging in a number. What we're going to be plugging in is an equation. And so it's going to look a little weird. Now the typical way that this is written is with f, we've got a little circle in between, and then we've got g of x. Now what's that's going to mean is whatever g of x is gets plugged into the f equation. So it would look something like this, where this is an actual equation. It will replace whatever x is throughout the entire equation. So let's kind of take a look at how this is going to play out. So let's say I've got f of x is equal to x squared minus 1. I've got g of x is equal to the square root of x. So if I'm starting off with f of 3, that means in my equation, if I start off with x squared minus 1, I can see that the 3 has replaced my x, so it has to replace x here, and that would be 3 squared minus 1. I work it out and I get 9 minus 1, or 8. I do the same thing with f of 5. Now this time x is 5. And so I'd have 5 squared minus 1 is equal to 24. Do the same thing with negative 2, where I plug negative 2 in for x now. So negative 2 squared. Now remember, when we have those negative values, we want to make sure we're putting them in parentheses before we evaluate in the calculator. And so that would give us positive 4 minus 1 is equal to 3. Now down here we see f and then that symbol for composition, f composed with g of x. Now the way that would look is we're going to have f of g of x. Now what did we say g of x was up here at the top? G of x is the square root of x. So so really what we're going to be plugging into the equation, we're going to treat it like if we have f of the square root of x. And again, just like up here, whatever is in these parentheses has to be plugged in for x. And so we're going to end up with, in the parentheses now, my x is square root of x squared minus 1. So the only difference is I plugged in this square root of x instead of a number like I was doing earlier. So I do have to simplify this equation, and so the square and the square root cancel out, and we're just simply left with x minus 1. So if I continue on, because we had a couple additional problems up here, we had g of 4. So g of 4 means I'm going to find my g equation, which is up here, and this time I'm going to plug in the number 4 to the equation, so I'd end up with the square root of 4, which is 2. If I find g of 7, I would plug 7 into the g equation, which will give me the square root of 7. Now that doesn't simplify any, so at that point I can't really do anything with it. That's my answer. Now the next step, I've got g composed of f of x. Now what we were saying is that whatever comes second is going to get plugged into the first letter. This is going to be read basically g of f of x. Now f of x, we said earlier, was this right here. So I'm going to make that substitution. I'm going to replace what's in the parentheses here, just whatever x squared is, or the x squared minus 1, which is what f of x was. Now whatever's in the parentheses, it doesn't matter what it is, has to get plugged into that equation. So this time I'm plugging in x squared minus 1 into my square root equation. And so I've got x squared minus 1. At this point I can't really simplify it, so this is a finished example, and this is a finished problem. So my next example, it's going to be a lot shorter than the previous one. We've got f of x is equal to 3x plus 2, g of x is equal to x minus 1. The first thing I'm asking you for is f composed of g of x. So again, g of x gets plugged into the f equation. So we have f of g of x. But what is g of x? So we just said g of x is x minus 1. So I'm going to plug x minus 1 into this equation right here in the exact same spot. Now I know whatever's in the parentheses here has to get plugged in for x right here. It's going to replace whatever x is. That's how we evaluate the equation. So we end up with 3 parentheses x minus 1 plus 2. Now we don't typically like seeing equations like this, and so we are expected to simplify this expression. So I'm going to start by distributing in, and so I'm going to end up with 3x minus 3 plus 2. I see some like terms here, and I get 3x. Negative 3 plus 2 would give us minus 1. And there is my composition. So our next equation said we wanted to find g composed of f of x. So f of x is getting plugged in to the g equation. So when I'm looking at this equation, I know my f of x, what's going to get plugged in here is going to be what's up here, because that's what f of x is equal to. So I've got 3x plus 2. So when I try to figure this out, I'm going to plug that in to my original equation of x minus 1. So I'm going to end up with 3x plus 2 minus 1. I'm going to simplify the expression. So I don't have anything to do inside these parentheses. And so I've got simply 3x plus 2 minus 1. Now I want to combine my like terms. I see the 2 minus 1 gives us 3x plus 1. Our next equation, we're going to start by finding f composed of g of x. So g of x gets plugged into the f equation. So I'm looking for f of g of x. Now I know g of x, this whole part right here, what's going to get plugged into the equation is this square root of x plus 1. So really what's getting plugged in for x is the square root of x plus 1. When I plug that into my equation, again I'm going to use the parentheses to plug my x in, just like we did at the very beginning. I've got this x plus 1. Now what do I have to do? And this right here is my x. This right here is my x value. And so it's a lot different just thinking about it as x is actually an equation this time. Now I see that it needs to be squared minus 2. Now I need to simplify. So the square root and the square will cancel, and I'm left with x plus 1 minus 2. I combine my like terms, and I have x plus 1 minus 2 would give me x minus 1. And there's a little bit more that we'd have to do on this problem, which is what we're going to be looking at in class. So let's say if I'm looking for g composed of f of x. So this time I'm going to be plugging f of x into the g equation. So I've got g of f of x and I know f of x is equal to x squared minus 2. So that's what's going to be plugged into my equation this time. So I start off with my g equation, which is x plus 1, but the value I'm plugging in for my x is what is right here, which is x squared minus 2. Now we'd need to combine our like terms, so we've got the square root of x squared. Negative 2 plus 1 would give us minus 1. I cannot simplify this any further, and so there is my g composed of f. Alright, we'll do one last example of just a regular composition. So this one, I want f composed of g to start. So g will be plugged into f. We've got f of the square root of 1 minus x squared. I plug that into my equation. So I need to have x squared. So I've got the square root of 1 minus x squared. That will be squared. Now the square and the square root will cancel like normal. I'm left with 1 minus x squared is equal to my composition of f composed of g of x. Now if I'm looking at g composed of f of x this time, so the equation f of x gets plugged into the g equation, and I'll have g of x squared. Now whatever is in the parentheses gets plugged into the x right here. So I'll have 1 minus x squared, but then I also have this additional squared from the g equation. Now we have to think back to our rules of exponents. When we have a situation like this, we should remember that we should get x to the fourth here because we're going to multiply our exponents. So the squared times 2 would give us x to the fourth. Now we have just a couple more examples. This time we're going to use some numbers. So this first one says f composed of g of 3. Now we're going to treat it the same way, just instead of using x at the end, we're going to use 3 at the end. It's basically to plug in a number and still get a value. So we have so we've got g of 3 is going to be plugged into the f equation. So we got f of g of 3. We're going to set it up the same way. We've got f. Now g of x, so we need g of 3. If I'm looking at g of 3 here, that would tell me I'd have 3 plus 1. So over here, g of 3 would be the 3 plus 1. Now we can work that out ahead of time and just say we're really looking at f of 4, which would tell me to plug into the f equation. So I've got 2 times 4 minus 3 will give us 8 minus 3, or 5. The next value we have is g of f of negative 2. We're still going to look at it the exact same way we did the last one. So I've got g composed of f of negative 2. So I'm going to have g, and then for f of negative 2, I have 2 negative 2 minus 3. And so when I work this out, 2 times negative 2 would give us negative 4. Then we've got minus 3 would give us negative 7. So g of negative 7, I'd have negative 7 plus 1 is equal to negative 6.